अस्सलाम वालेकुम स्टूडेंट्स, उम्मीद करता हूँ आप खैरियत से होंगे। जी स्टूडेंट्स, हम चैप्टर नंबर 2 जो हमारा एटॉमिक स्ट्रक्चर है, इसके के तमाम इम्पोर्टेंट शॉर्ट क्वेश्चंस जो हैं वो इस वीडियो में देखेंगे। इसमें मतलब हमारे एक्सरसाइज के भी आ जाएंगे, जो शॉर्ट क्वेश्चन है, कंस्ट्रक्टेड रिस्पॉन्स क्वेश्चन है। मतलब इस वीडियो के अंदर हमारे जितने भी ऑल पॉसिबल एंड इम्पोर्टेंट शॉर्ट क्वेश्चन फ्रॉम दिस चैप्टर हमारे इंक्लूडेड है। अच्छा बेटा, इस चैप्टर का वन शॉट वीडियो मैंने अपलोड कर दी है। वन शॉट मतलब एक ही वीडियो के अंदर पूरे का पूरा चैप्टर, क्या लॉन्ग क्या शॉर्ट, ईच एंड एवरीथिंग। लेकिन बच्चे फिर भी कहते थे कि सर हमें ना इनको मतलब क्वेश्चन आंसर की फॉर्म में इंपॉर्टेंट क्वेश्चन बना दें। तो बेटा मैंने क्वेश्चन आंसर की फॉर्म में जितने भी पॉसिबल क्वेश्चन है वो बना दिए हैं, तो आप वीडियो सुन सकते हैं। ये सारे क्वेश्चन हैं, इनको नोट कर लें। क्वेश्चन इंपॉर्टेंट हैं, आंसर मैंने लिख दिए हैं साथ, लेकिन इनके क्वेश्चन को माइंड में रखिएगा। अगर आंसर आप अपनी तरफ से भी लिखना चाहते हैं तो वो भी ठीक है, इस वाले लिखना चाहते हैं वो भी ठीक है। तो चलें शुरू करते हैं।
Is Dalton's atomic theory?
According to this theory, it is not possible to divide atoms into smaller particles.
What experiment led to the discovery of subatomic particles?
The discharge tube experiment led to the discovery of subatomic particles.
What did scientists discover about atoms during the discharge tube experiments?
Scientists discovered that atoms are not the smallest particles of matter. They are composed of smaller subatomic particles, electrons, protons, and neutrons.
What are the charges of electrons and protons?
Electrons are negatively charged, while protons are positively charged particles.
How much heavier is a proton compared to an electron?
A proton is 1836 times heavier than an electron.
How was the presence of negatively charged particles confirmed in the discharge tube?
The negatively charged particles, electrons, were confirmed because they were deflected towards the positive plate in an electric field.
How was the presence of positively charged particles confirmed in the discharge tube?
The positively charged particles, protons, were confirmed because they were deflected towards the negative plate in an electric field.
What is the approximate size of the nucleus compared to the atom?
The nucleus is less than 100,000th, that is, 1 upon 100,000 of the size of the atom.
What percentage of an atom's mass is contained in the nucleus?
The nucleus contains more than 99.9% of the atom's mass.
What does the fact that the nucleus contains most of the atom's mass imply about electrons?
It implies that electrons contribute very little to the overall mass of the atom, as most of the mass is concentrated in the nucleus.
What is a discharge tube? A discharge tube is a hard glass tube with two metallic electrodes and a vacuum pump to evacuate the gas. What are cathode rays? Cathode rays are the rays emitted from the cathode when a high voltage is applied to an evacuated glass tube, a discharge tube. Who studied the properties of cathode rays and in which year? British physicist Joseph John Thomson studied the properties of cathode rays in 1897. How did Thomson prove that cathode rays are negatively charged? He passed cathode rays through oppositely charged electrodes and observed that they bent towards the positively charged plate, indicating a negative charge. What was observed when Thomson placed magnets on either side of the discharge tube? The cathode rays were diverted by the magnetic field, proving that they are charged particles. Who first observed the presence of positively charged particles in an atom? The presence of positively charged particles in an atom was first observed by E. Goldstein in 1886. What was the basis of Goldstein's experiment? It was based on the concept that atoms are electrically neutral, having the same number of positive and negative charges. What kind of rays did Goldstein discover in a gas discharge tube experiment? He discovered canal rays or anode rays which were produced from the anode and moved toward the cathode. What conclusion did Rutherford draw about the hydrogen nucleus in the gas discharge tube experiment? Rutherford concluded that the hydrogen nucleus or proton is the fundamental building block of all atomic nuclei and might also be a new fundamental particle. Why are cathode rays named so?
Cathode rays are named because they are emitted by the cathode in a discharge tube.
How are positive ions formed inside the discharge tube?
The high voltage ionizes the residual gas atoms, producing positive ions.
How are cathode rays produced?
When positive ions collide with the cathode, they knock electrons out of its surface, forming a stream of electrons called cathode rays.
When was the neutron discovered and what is its charge?
The neutron was discovered in 1933 and it carries no charge.
What are the three fundamental particles of an atom?
The three fundamental particles are electrons, protons, and neutrons.
What were Rutherford's conclusions from his experiment?
He concluded that an atom consists of a tiny central portion called the nucleus and a larger surrounding area called the extranuclear portion.
What force holds protons and neutrons together in the nucleus?
A strong nuclear force holds protons and neutrons together in the nucleus.
Where are electrons located in an atom?
Electrons revolve around the nucleus in fixed circular parts called orbits or shells.
What are subshells and how are they related to shells?
Subshells are smaller divisions within shells, and the number of subshells in a shell equals its principal quantum number n.
Why do atoms of different elements differ from each other?
Atoms of different elements differ because they contain different numbers of fundamental particles, electrons, protons, and neutrons.
What is the atomic number of an element?
The number of protons present in the nucleus of an element is called the atomic number. It is represented by Z.
Why is the number of electrons in an atom equal to the number of protons?
Since an atom, as a whole, is electrically neutral, the number of electrons is equal to the number of protons.
What is the mass number of an atom?
The mass number, or nucleon number, is the total number of protons and neutrons present in an atom. It is represented by A.
What is Copernicus, Cn, and when was it discovered?
Copernicus, Cn, is a synthetic element discovered in 1996.
Calculate the number of neutrons, protons, and electrons in the following atoms: 19578 pt, 25 mn, 12753 I.
Pt, Z is equal to 78, A is equal to 195, neutrons is equal to 117. Mn, Z is equal to 25, A is equal to 55, neutrons is equal to 30. I, Z is equal to 53, A is equal to 127, neutrons is equal to 74.
How would you compare the masses of the atoms of Mg and Cl?
Mass of Mg is 24 AMU. Mass of Cl is 35.5 AMU. Dividing 35.5 by 24 gives approx 1.48. So a chlorine atom is approximately 1.5 times heavier than a magnesium atom.
Why is it said that almost all the mass of an atom is concentrated in its nucleus?
Almost all the mass of an atom is concentrated in the nucleus because both the heavy particles, that is protons and neutrons, are found to be present here.
Why are elements different from one another?
The difference in the properties of elements is due to the difference in the properties of their constituent atoms having unique atomic numbers.
How many neutrons are present in Bi? Z equals 83, A equals 210.
Atomic number Z is equal to 83, atomic mass A is equal to 210, number of neutrons N is equal to A minus Z is equal to 210 minus 83 is equal to 127.
Why does the energy of an electron increase as we move from the first shell to the second shell?
The energy increases because the electron moves farther from the nucleus. The nucleus has a strong attraction for electrons, so more energy is needed to keep an electron in a higher shell.
Why is it needed to lower the pressure of the gas inside the discharge tube?
The pressure is lowered to allow gas particles to move freely and collide with high-energy electrons. This helps create plasma, making the gas glow as electricity passes through.
What is the classical concept of an electron? How has this concept changed with time?
Classically, an electron was thought to be a tiny solid particle orbiting the nucleus like a planet. Modern theory views electrons as charged clouds, probability, where location cannot be predicted with 100% certainty.
How can scientists synthesize elements in the laboratory?
Scientists synthesize elements by using nuclear reactions. Using particles, protons, neutrons, they force nuclei to merge, forming new heavier elements that may not exist naturally.